method of solving quadratic equation, the completing the square method of solving quadratic equation. I want to believe you're following. Now, let's see. Let's pick an example here. I have some questions here. I'll just write one down. X squared plus 2x plus 9 equals to 0. Now, the question now is this. If the factorization method of solving quadratic equation was successful, was just perfect, was just enough, why then do we need the completing the square method? What is the essence of having, or having the completing the square method? What is the reason? So that's what we just want to look at now. What's the essence of using the completing the square method? So the reason is because there are some quadratic equations that cannot be solved using the factorization method. All right, for example, the one we have on the board here, some cannot be solved using, or cannot be factorized. Some quadratic equations cannot be factorized, and let's try and see if we can factorize this. So I have this bracket here, and like we earlier explained, I said you have to multiply the coefficient of x squared by 9 to give you, that's 1 times 9 will give you what? 9. All right, so now what factors of 9 can be multiplied to give us 9? We have 1 times 9. We have 3 times 3. Aside this, we don't have any other factor that can be multiplied to give us positive 9 except this. The next thing again is that we're going to ask ourselves, what factor, which of these factors can be added together to give us plus 2? Now, I want you to play with your intelligence and play with your mind. Is it possible for us to add any of these factors together to give us a plus 2? It is not possible for us to add any of those factors. In that case, we can say that this particular equation is not what? Factorable. It's not factorable. All right, cannot be factorized. This particular equation, quadratic equation, cannot be factorized. So with this, it creates a need, therefore, for us to employ a methodology that can be used to address equations like this. And that is where completing the square method becomes very handy. Now let's see how we can apply that. Now, the method of completing the square method, the first thing we do is what? We have to take the constant to the other side of the equality sign. That will be x squared plus 2x equals to 9 minus 9. Since we have a positive there, is going to be a minus 9. Minus 9. Right. So now, the next thing we are going to do will be for us to take the square of the coefficient of x. The square of half the coefficient of x will be added to both sides of the equality sign. I am going to explain why. I'm going to explain why in the process of trying to solve this, of solving this. Now, we're going to take half the square of the coefficient of x. What is the coefficient of x here? 2. What is half of 2? That's 2 divided by 2. Then this is what we're adding to both sides. Half of this is 2 divided by 2 is half of 2. Then we're adding it to both sides of the equation. All right, so 2 divided by 2 is going to give us what? 1. All right, so we're taking 1 squared. We're adding 1 squared to both sides, right? So now let's go ahead and do that. And in solving mathematical problems, you are allowed to add or subtract whatever you want to do. Whatever you want to solve, if it leads you to your required solution. So there is no issue at all. But what you have to do is that whatever you're doing to the left side, you must do same to the right side. That is just the principle. You cannot add just to the left and not add to the right, in order to be able to balance the what? The equality sign. So let's go ahead and add the half the square of the what? Coefficient of x squared, which is 1 squared. Now we're adding that to both sides. It will be x squared plus 2x plus 1 squared equals to minus 9 right, plus 1 squared. This will be equals to minus 9 plus 1 squared is 1 plus 1 will be equals to what? Minus 8. So let's just leave this here and come over to this side. Right, let's come over to this side. So now what we have here is the next thing we're going to do is to take the square, the perfect squares in this side of the triangle, or in this side of the polynomial sign, sorry. So now it's going to be x squared plus 1 squared. That's what we're doing. That's the next thing to do. We've taken the squares of this side. All right. So now we'll be right to just, we can still have it in a bracket. 1 all squared will be equals to minus 8. Minus 8. Now, what we have here is what? Is x plus 1 times x plus 1. That's the meaning of this. So let's try and factorize this. Let's just work, let's just factorize and see what happens. X times x is going to give you what? X squared. X times 1 is going to give you x. 1 times x is going to give you what? X. 1 times 1 is going to give you 1. Right? So now let's see what happens. X squared plus 2x plus 1. That's what we're having. Now, if you pay attention, all right, if you pay attention to this, to what we have here, and compare it to what we have here, all right, it's just the same. Well, it's just the same. There's no difference. So that's why we decided to take the square of this. We took the square of this and we decided to bracket the square of that, and we're bringing this. So this is still the same as this, because by the time you square 1, it's still going to give you what? 1. So that's just what you have there. All right. So this is just the same as this. So that's why we often, most times, we have to take half the square of the coefficient of x. And the essence of that is that, remember, at the initial point, we could not factorize this. We could not factorize this. Now, we decided to create an equation in an equation. We created a new equation inside this equation to enable us factorize what we have here. That's the essence of adding half the square of the coefficient of x to both sides. By doing this, we have created a factorizable equation. All right, so we decided to factorize it to carry on with our equation. What we added here, we're able to add it there, so it doesn't affect anything at all. The essence of this is to arrive at a final solution. I don't know if you're satisfied with that. It's making a lot of sense. So let's go on. Now, the next thing we're going to do will be to square both sides. All right, we're going to square both sides. We're going to take the square root of both sides. Why? Because we want to cancel this. So that if we're taking the square root of both sides, it's going to be x plus 1 equals to plus minus the square root of what? Minus 8. That is what we'll be having. All right. So the square root of minus 8. All right. So now let's equate our x, meaning we're taking this to the other side. So it's now going to be 1 minus 1, right? Minus 1 plus or minus the square root of minus 8 because we're having minus 8 here. Here, we're having minus 8 here. All right. So now we're just going to work on this. Obviously, we're going to have two roots from this. The first one is going to be minus 1 plus square root of what? Of minus 8. Or we're going to have minus 1 minus the square root of what? Minus 8. So these are going to be the two roots. Okay, these are going to be the two roots. So we don't want to have this in decimal. I don't want to have this in decimal. And also, if I had a factor of 8 that was a perfect square, it would have been easy for me to multiply the two factors that can give me 8 and then find the square root of that particular factor. But since I don't have it, I'm going to leave it at this for now. All right, I'm just going to leave it in this form. All right, so meanwhile